Suresh, Dr. Kusmarao, and all the participants of this Vasamsa 2022 program, Dr. Ramesh. It's indeed a privilege to be part of this program and talk to you about what ISRO has done during the last few decades in providing the observations from space to the weather community. ISRO started its activities of getting into the process of using space technology for societal benefits from the early period of 60s, where the sounding rockets were used to study the upper atmosphere, particularly the upper atmosphere at the geomagnetic equator near Tumba was the starting point, where atmospheric profiles up to 80 to 100 kilometers were the sort of activities which started. Stratospheric warming and its impact on monsoon. And then ISRO, of course, while building its own capability of putting observation system, was also enabling the making the availability of data generated from other international programs, whether it is the Coastal Zone Color Scanner or Nimbus, CSAT. And then we started our own program with 1979 Bhaskara, which carried a Samir payload passive microwave radiometers. And then by 96, of course, we also had Peace 3, where ocean color observations were done, and also a large number of multi-band and multi-wavelength observations of atmosphere were being provided. The real atmospheric data, of course, started in the 80s with the availability of INSAT series, where India actually provided, by bringing in a unique combination of a single geostationary satellite covering broadcasting, communication and weather, all three in one. And at that point of time it was a novelty because of the, you can say, the India's ability to put a lot of resources in that. It was trying to find innovative ways of making use of space technology. And INSAT 1 series provided 2 channel observations, one in visible with 2.75 kilometer resolution and another in thermal infrared with 11 kilometer resolution. That is when India started providing the cloud and cloud motion information. And then gradually, starting from that, by the time we came to the 90s, we had our own satellites built, and the INSAT series with VHRR, very high resolution radiometers, providing 2 channels, visible and thermal infrared, increasing to 4 images per day. And then by 99, we had our own Kalpana satellite, which added one more channel, 3rd channel, water vapor channel and thermal infrared channel. And now we have in fact INSAT 3D and 3DR, 2 of them both carry imager and sounder. Imager is a 6-channel instrument connecting visible, shortwave infrared, microwave infrared and water vapor and thermal infrared, 2 channels. And a combination of 3D and 3DR is providing almost 48 images per day. And this combination provides an opportunity to capture short-lived cloud processes and a large number of AMVs, then structural changes within cyclone during rapid intensification, and these stages are captured. What we have is 1 kilometer resolution in visible, shortwave infrared and middle infrared. All this, in addition to that, India is among the only other country to provide a 19-channel sounder, which is capable of making observations in 18 channels and 1 visible channel, enabling 40 profiles of temperature from surface up to 70 kilometer and 21 profiles of humidity and integrated ozone data. And all this data is also being actually calibrated, making use of the international global space-based intercalibration system, wherein the data collected from these instruments are actually compared with the G6 observations, and then this coefficient information is also provided on a regular basis for making sure that the users can confidently use this data. While it's clear that looking at atmosphere from space actually is going to be hindered in many ways because of the cloud presence, while cloud itself is what you want to see, but cloud also masks a lot of other information which you can extract. But then use of microwave signals helps you in seeing through the clouds, and right from the early stages of 79, starting with Samir, India developed the various microwave instruments. Initially it was all scanning microwave radiometer, which was capable of providing sea surface temperature, wind, and then cloud information. Then we had our own scatterometer, which contributed to the wind vector information. In fact, it's all quite clear that with the availability of space-based observation, almost 3/4 of the globe in situ data on wind vector is the one which made a significant impact on weather prediction. And we started providing our own scatterometer data, not only to India, but also to the global community. Within 3 hours of acquiring this data, this information was being provided. Also worked with other international space agencies, whether it is for megatropics, which enabled instruments like Madras and Sophia. So I was talking about the use of microwave instruments, and then whether it is the Madras Sapphire as part of megatropics, or Saral Altica, which provided the altimeter information to the global community, and also a number of microwave instruments are all becoming part of the data that is being generated and provided to the weather community. And this shows, of course, some more details on the megatropics, which served almost 10 years of operation. Now, of course, megatropics is no longer in operation, but for almost a decade, it provided extremely useful information on the radiometer and the 6 channels in the microwave, and also long wave radiation fluxes and temperature and humidity profiles, in addition to the instruments like radio occultation observations. And what ISRO also did was providing a complete INSAT meteorological data processing system, which was made operational at IMD by establishing specific observation reception station, and also all the processing chains of receiving the data from geostationary platforms and providing this data to the as input to the weather forecasting systems at IMD. And this started becoming operational in the mid of 2000, and also provides rapid for visualization of the data. That is, rapid is nothing but real-time analysis of products and information dissemination system, and this also is been made operational and provided to the weather forecasting community in the country. Scatterometer, like I said, we started with the scatterometer starting from 2009, and where the KU band data was being provided, and almost 14 orbits per day, and data disseminated to the international community of weather forecasters, NASA, NOAA, EUMETSAT, KNMI, and ECMWF, etc. In all this, of course, the tropical cyclone prediction, cyclogenesis, and scatterometer gave us the significant opportunity to improve on the ability to do cyclogenesis information. And this slide does show the kind of data that could be generated from scatterometer, which provided very useful inputs, and also the observational tropical cyclone, the activities using Sapphire, and the importance of microwave data going into this was also actually became apparent with this. Of course, today, over the period, what the ability to provide satellite-based observation has shown is in the disaster management of tropical cyclones. Compared to the earlier period, the improvements are quite significant, both in terms of reducing the area of uncertainty and also the time error in predicting the cyclone landfall, which has made a huge impact in the country. and all the super cyclones in the earlier decades, which used to cause deaths of thousands of people, today with the significant efforts by IMD and disaster management agencies, is able to bring down the loss of lives to single digit numbers, and continuous progress in this is being done with more and more observations being added to the capability of weather forecasting community. And other things that are happening is very high impact weather events, both satellite and radar based information for storm tracking, nowcasting, and also microphysical studies. Some of these activities are going on. And then air pollution monitoring is again another very important aspect based on the space-based observations of 3D and 3D imager derived aerosol optical depth and dust storm linked air quality monitoring. The information is being provided. And in addition to that, IMD has also made sure that the data available from INSAT is actually provided through agromet products and agromet product dissemination to the farmers in the country through the various digital gadgets that are available today in the form of whether it's mobile or other devices, and agromet products from INSAT has become a routine now. And also using crop prospects, using operational daily soil moisture and vegetation index, and there are also other portals which have been established. One of them is Vedas Geo portal, which provides information not only what is collected from our own Indian satellite, but also from satellites across the globe for which MOSDAC has access. And I'll also show subsequently how MOSDAC is providing a host of information. And operational weekly dryness index based on INSAT derived data is provided. And also decision support system for pest advisory is also part of the activity, whether it is for the mustard aphid forecast or high resolution rainfall prediction system. The ability of providing such information is making a significant impact in the activities that are going on. Another very important aspect that has been done is rip currents in the almost 21 beaches across the country. The impact of these rip currents as a forecast is being provided. And then while space-based observations are necessary for you to generate information over inaccessible region, its validation is also required, and for validation you need to develop a large number of ground systems, whether it is agrometeorological stations or automatic weather station, boundary layer monitoring or Doppler weather radars, wind profiles. In all this, ISRO also carried out developments on the ground and established capability in the country, which is now getting more and more operationalized with IMD trying to bring in a larger number these weather radars and other radars. And in fact, part of the discussions in this particular symposium is also to see how weather radars or radar information from space can make an impact in the activities. Now, wind profiler is another important development that has happened as part of the ground system. 53 megahertz, 49 megahertz, 200 megahertz and 430 megahertz. In all this, developments have happened indigenously and capability exists, but then the need is also to make sure that this capability is harnessed and opportunity provided to the manufacturing capability existing in the country and establishing these observations. So advanced data visualization and analytics is another thing that has been provided, whether it's for animation or for search and measurements or overlay of ground observation for all this. And then information products, this is available at MOSDAC. And MOSDAC is in fact providing all these capabilities. And in fact 3D visualization of clouds, including three-dimensional rendition of cloud and snow products. And another very important development that has happened is what ISRO is doing at Ahmedabad, providing support to students and academics and researchers for pursuing research in meteorology and oceanography, where the data collected not only from Indian space-based observations, but also what is accessible to us through the cooperation with the international space agencies. All this data is made available to the researchers. Researchers can spend time, they can not only get access to data, but also the computing systems. And as a result of such smart, what is called as a SMART program, Satellite Meteorology and Oceanography Research and Training, this activity has actually taken off, and a large number of academic institutions and students are working on that. These are some of the results of what is done by the student groups, whether the Cochin University or Indus University and also Anna University students have worked. And in fact, institutes like this should also need to promote the opportunities available, where unless we get into the process of looking at the data collected in the past and make sense out of that with today's technology of whether it is machine learning or artificial intelligence, our ability to learn and interpret things remains limited. And it is in this both MOSDAC and also the portals that are available at various facilities of ISRO can be made extensive use of. And in addition to that, recently we also had a very high resolution imaging sensor operating from geo platforms, which is actually trying to show in 6 different wavelengths it can generate images over India every few hours. The data can be collected. This data is also available for research community, and to see what can be done. You can see super resolution cloud images deriving the depth and height of the clouds is possible using that, and a lot of R&D needs to happen on this before such instruments can become operational. So what I was talking about is MOSDAC today provides Indian storehouse for meteorological and oceanographic data, and it contains almost 3 to 4 decades of data of INSAT series, and not only our own data, the megatropics or scatterometer, but also the data hosted from NASA, NOAA, and also the European and Japanese systems. And it also provides for data analytics and visualization. And today, if you get into the portal, there are a lot of live activities which are going on. And not only that, it's also connected with the Committee on Earth Observation Systems Integrated Catalog, what is called QUIC. And this also provides all the metadata requirement as demanded by CEOs. And this also is in a way, you can say, treasure house for weather researchers. So that in a nutshell is what ISRO has done in the area of atmospheric research, both providing satellite-based observations and also developing ground-based in situ observations to enable use of this satellite-based data, not only doing what the country is able to put its resources and put space-based observation, but also working with international cooperation with other space agencies for both bringing in data collected from others, making it accessible to the requirements within the country, both for meteorological research as well as for the student community, and providing through the various portals the collected data and making it accessible to the community has been the endeavor. And of course, no amount of work is sufficient, because the kind of problems that we are facing and the magnitude that of difficulty that exists in tropical weather forecasting is lot more than what one sees in temperate or other zones, where the predictability is said to be much better. But then today's changing scenarios, just now also we are seeing that the monsoon in the northeast, you are having very heavy rains for few days and then almost like heat wave type of thing, and what China also has reported, a series of disasters following each other. The manner in which it is happening is a real challenge to the community, to the scientific community to understand and then make sense out of this and give sufficient warning to the people so that their tomorrow can be better. But for doing that, they demand more observations, and more observations, whether it can come from global space-based activities or in situ activities. All this requires technological challenges, more and more newer ways of making observations of parameters of interest, and these are the challenges that exist. And if these challenges have to be faced and overcome, it is only when more and more people get into this process of doing such things, that is where our ability to enthuse the next generation to get into this process and bring in more and more research activity, it's important. And it is in this context I should compliment IIRC for taking up this task of bringing in the topic which is very relevant for the day-to-day living on this planet Earth, and making sure bringing the various people who are involved in this activity together, make them discuss and think and bring direction and give probably pointers to those who are going to build and make systems, both in terms of those who are in the power and pointing out to them. That is where events like this are important. So let me compliment IIRC for carrying out this work, and also wish all of you a 4 days of very intense and meaningful interaction, at the end of which where you would be in a position to point out what should be done and how things should be taken forward in the future. Thank you very much.